All right, section 2.1, we're going to look at examples 1 and 2. So example 1, we've got matrix A and matrix B. They want us to find A plus B. When you add matrices, your matrices have to be the same size, so they have to have the same exact dimensions. So this is a 2 by 3 matrix and a 2 by 3 matrix, which means I can add them, and when I add them, I'm going to get another 2 by 3 matrix, and I get that matrix by adding the elements that are in the same spot. So -2 plus -6 gives me -8. 0 plus 7 gives me 7. 1 plus -1 is 0. 0 plus 4 is 4. 5 plus -3 is 2. And -8 plus -8 is -16. So it says, what would happen if we did B plus A? So if we did B plus A, I'd take the elements in B and add them to the corresponding elements in A, and we would end up with the same matrix for my answer. So with matrices, addition is commutative. Okay, which means A plus B is going to equal B plus A. If you switch the order with adding matrices, that's okay. It doesn't make a difference. So now we have matrix C and D in example 2, and we want to do C minus D. So again, they have to be the same size. I've got a 3 by 2 matrix, a 3 by 2 matrix, so I can do my subtraction. I'm doing C minus D, so I take an element from C and subtract the corresponding element in D. So 9 minus 8 is 1. 4 minus a -2 is like 4 plus 2, so I get 6. -1 minus a -6 is 5. 3 minus 1 is 2. 0 minus 5 is -5. And -4 minus a -5 gives me a +1. And it wants to know what would happen if we did D minus C. So if I did D minus C, let's check this. 8 minus 9 would be -1. -2 minus 4 would be -6. -6 minus a -1 would be a -5. 1 minus 3 would be a -2. 5 minus 0 would be 5. And -5 minus a -4 would be a -1. So if you compare that to what I got when I did C minus D, we see that D minus C is the opposite of C minus D. That means that subtraction is not commutative. So the order matters on that. Okay, subtraction is not commutative.